Hello everyone, thank you for coming to the second seminar in this Computational Toolkit series. My name is Charlotte and I'm a second year Hetsys PhD student here at the University of Warwick. Today we are going to be looking at data visualization in Python and mainly focusing on how to use the Matplotlib Python package. So, first things first, here is a brief overview of what we are going to be looking at today in this seminar. It includes a brief introduction to what Matplotlib is, the important basics including how to import the module, plotting your first graph, how to customize those graphs, how to make subplots, and introduce different types of plots you can make. Then I will go over some more advanced features and examples of some of those graphs in the last section as well. Throughout this seminar, I will try and include snippets of code wherever possible. What I would suggest is trying to replicate some of these examples yourself and even extend beyond what I'm going to go through today. The easiest way to learn how to use Matplotlib is to do just that, use it. So try and find as many examples as you can online and put into practice what I'm going to show you today. Now, there is so much you can do with Matplotlib, too much to cover in just one session, so the aim of this seminar is to give a brief introduction into the basics of Matplotlib, which will give you a good foundation to attempt more of the complex plots seen towards the end. So, to get started, we first need to know what Matplotlib actually is. So, Matplotlib is a widely used Python package for visualizing data. It is widely used in academia and industry, and it benefits from extensive documentation, as well as it being free and open source. So the documentation is available through the link given at the bottom of the slide there, and the documentation mainly goes through the format of each plotting function, plus a variety of examples including the code, ranging from simple scatter plots to more complex 3D plots and even to animation. I did want to note that sometimes you may see, if you're looking at how to solve an error, for example, reference to something called Matplotlib PyPlot. So PyPlot is a module contained in the Matplotlib package, which provides a MATLAB-like interface. So if you have a MATLAB background, it may be worth looking into using this, as you may already use it, and also the code format may be a bit more familiar to you. So now we come on to installation. So installation is really, really easy and very easy and most likely the same on every operating system, and it can be done through your command terminal. So the first statement, which refers to pip install, is basically to install pip, which is commonly used to install Python packages very easily. So most likely you'll probably already have pip installed, but it's always good to do this if you're unsure, just to get the most up-to-date version. After that, to install Matplotlib, it's just a case of entering the second statement. This will install the latest stable version of Matplotlib available, and once you've done that, you are free to use Matplotlib in your Python scripts. If you have the Anaconda software, you can easily install it through the command in the terminal shown in the bottom image. Once you have successfully installed Matplotlib, in order to use it in your Python scripts, you need to import it. This is typically done for most modules, regardless of which one you're using at the start of the script. But if that's not the case, it is essential that it is imported before any code relating to that module is used. This needs to be done in every Python script that you use it in. In this case, we are using a shortened version such as MPL or PLT. So PLT is the more commonly used one, but they both represent the same thing. You don't have to use that. You could use any combination of letters that you want, but it's just typically easier and common practice to use PLT. So this saves you writing out the full Matplotlib letters every time before a function, and it also makes the code look cleaner and more readable. So now we're going to move on to actually plotting our first graph. In this example, we're going to plot a simple sine graph, and first things first, we need to import Matplotlib, which is done in the first statement in that code snippet. I've also imported the module NumPy just to help generate some data. So first, we create our X data. The NumPy linspace function in this case generates 100 data points ranging from 0 to 15, all equally spaced. and these are going to be our x values. Then, to begin plotting, we first plot the code plt figure. So this basically says to your code that you are creating a new figure, basically. It's not necessary. You don't have to do this every single time you want to plot something, but it can be good to get in the habit of, especially if your code has like multiple plots, as sometimes if you're not very clear with where one ends and one begins, they can kind of overlap a little bit and you're not getting what you think you would. So the next step is to create our y data. So in this example, we just use the numpy sine function on the x data. So I've done this within the plt plot function, which is where you actually tell the CLUD to plot your data. So this function takes in x values in the first space and then also the y values after it. So once that is done, in order to show the plot, we just use plt.show, which will output the resulting plot when the script is run. And as you can see from the plot, we have a sine wave as expected. So plt plot doesn't always take 2 input variables. You can also just put 1. However, this is just going to give you your x data with the x-axis in this case being the point number, and then the y value in this case being the value of that x number. It doesn't really tell you much, and it's not really what we wanted. So another thing to mention is you also don't need to calculate the y data within the plot function. You can easily calculate the y data before you use it and store it in a variable and use it just like you would the x data. Both of these ways are completely fine and lead to the same result in the end. So now that we have seen how easy it is to plot simple data, it is worth going over how to add axes, labels and titles to your graphs. It's always good practice to include axis labels and titles to your graphs, as it helps people understand better what your plots are trying to show. So this can easily be done by the 3 functions added to the code here. So we have plt x label, y label and title. Labeling the axes and titles must be contained in quotations, which shows it's in red there, if you want to input text. If you didn't want to input text and maybe you wanted to input a variable value, you would just put the variable name, but bear in mind it would only give the value of that variable rather than the name of the variable. So now we know how to plot a simple dataset. How do we plot multiple datasets on the same graph? Well, it's really simple. All we need to do is add another plt plot line, same as previously done. So in this example, I have added in the cosine data to be compared to the sine data. So note that Matplotlib by default will make these lines different colours if the colours are not specified. You can add as many data sets as you wish, either individually or as a result of a for loop or function, etc. But now briefly looking at this graph, how do we tell which line is cosine and sine quickly? Well, we could spend some time figuring out which one is which based on our knowledge on what they should look like, but that kind of takes time and nobody really wants to do that. So in order to make it easier for other people, we can add a legend to our plot. This is done through adding both labels to our plot and also a legend. Both need to be present in order for the legend to appear, but you don't need to label every line if you don't want to. The label will always need to go last in the plot function as well. So as you can see there, it goes after the x and y data values. So label for sine and label for cosine. The plt legend function would also need to go after everything else, just because otherwise an error will arise, as it won't be able to find the labels if it's put before the plot functions. And then also as well, to help you along, by default, Matplotlib chooses the best place for the legend to go, or where it thinks it causes the least obstruction to viewing the data. It's not always correct, but most of the time it's a pretty safe bet. However, you can force it to change position to where you think it's best, and this is done by adding in the loc, which is LOC, and either the number or the location string defined in the table there. Now we move on to ways in which we can customize our graphs. There are so many different ways in which you can customize your graph to make them more readable, more visually pleasing, and also help visualize the data you're plotting better. So in this seminar, we are going to be going over the line style and color, how to change the limits of the axes, and also how to add grid lines. However, beyond this, you can also look at adding background colors and also text and equations to your graphs as well. So first things first, we can change the line style very easily. This is done by adding in a symbol in the quotations in the table of your desired line to put in the plot function. So in this example, the sine line is in the circle markers and the cosine line is in the dashed line style. This table is only a small list of the different line styles available, and it is well worth playing around with a few as it makes differentiating data a lot easier. Note the solid line style is the default style here, so you don't need to specify if you don't want to. So now you can also easily change the colors of the lines as well. This is done by the addition of the color input in the plot function just after the line style input if you have specified the line style. There will be a specific order in which these functions accept things, so it's always worth checking the documentation if you're unsure of the order. And it's also good to note that when you're dealing with colors, Matplotlib will only accept the American spelling, and it will raise errors if you use the English spelling, so just be aware of that. So in this table, I have added the shorthand symbols for the different colors. Once again, these are only a small sample of what you can use. They are the most commonly used ones, but you can get whatever color you really want. And you can also use the full version name string, as I've done in the example code there. So another way to format your graph is you can change the axes limits very easily. This is a good way to illustrate and zoom in on key details of your data, any key features that may arise, or you want to look at something in more detail. So for example, in our case that we had multiple peaks and troughs, and maybe I only want to see half of one. Well, this is easily done through the xlim and ylim functions. So in the main example with the graph attached to it, I've set the axis to be between -5 and 5, and the y-axis to be between 1 and 1, which it was at previously. And then as you can see, the plot only shows the data between those ranges. So you also don't have to specify a definite value for the limits. You can do them as a fraction of the max and min of your data, as also shown in the code snippet at the bottom. If you have a specified range in which no data is present, there will just be a blank space, and also the limits don't need to be symmetrical either. I could have easily gone from -1 to 6 for the x-axis, and that's perfectly fine. So another thing you can add is also grid lines to your plot very easily as well. It's just a case of adding plt.grid within your plotting code. And then within that function, you can also customize the grid further by either changing the color of the grid, the line style, as well as the line width as well. So now that we have gone over the basics of how to create a plot and also how to customize them as well, it's also worth going through some of the plots also available through Matplotlib. So here are a few basic plots such as scatter graphs and bar charts. In order to use all of these, all you need to do is just change the plot function to, for example, plot step, for example. Everything contained in the brackets, it can be considered the data input. So for most of these, it's the same as the one used previously where you have X and Y data. But this isn't always the case. For example, for the fill between function, you have X, Y1 and Y2. So there's 3 inputs that you need to put in there. So next we move on to a different plot type which illustrates arrays and fields. These are typically illustrated by contour plots as shown in these examples here. Note you will find 2 different types of contour plots, contour and contour F, with one representing the unfilled contour and filled plots respectively. but they both represent the exact same thing as well. There are also a lot of graphs relevant to statistics. It includes histograms, box plots, and also adding error bars to your plots, which can be very useful as well. So finally, we come on to another plot type, which is an extension of contours as well. So there are some great examples of how to use each of these plots covered online in the Matplotlib tutorial. These examples also include the code, which will help you replicate the plots yourself. They are well worth going through, and as you can easily adapt them to fit your data too. All of the plots shown on the few previous slides can be used in the same way as the plot function we use in our first example. So it's the same process to add axis labels and titles, etc. There may be some slight changes in how you would change the line style or color, so it's worth checking the documentation for the particular graph you are using. Now we are going to look at subplots, which is essentially multiple plots shown in the same output figure. In this example, instead of plotting both lines, both sine and cosine, on the same graph as shown in the previous examples, I have separated them and given them their own plots. So in order to do this, we need to use the subplot function, which is shown in the code at the top. So these numbers may appear a little bit strange at first, but they do have a meaning. So the numbers 211 at the top, so it goes in the order of number of rows, columns, and then the index of each of the plots. So in this example, we have 2 rows, as we have one plot on top of each other, and then 1 column. There's only just one in each way. The index refers to which plot you are dealing with. So the top one has an index of 1, and the bottom one has an index of 2. Now you don't have to have them on top of each other. If you wanted them side by side, then the number would just be 1, 2, and then the index you're referring to. So you can also add axis labels and titles in the same way as shown previously. All you need to do is just to make sure it is under the correct subplot function you want to add it to. So also as well, if you're looking at examples online, there is another way in which you can plot subplots, which you may see in example codes for it. This is done in a similar way in treating each graph separately, but uses the notation fig and ax as indices rather than using the index and numbers. So both of these methods are equivalent, and so you can choose which one works best for you. Now there are many more variations in which you can arrange a whole number of graphs if you want, and you can also include more than 2 graphs as well. I've seen some which include 16. Obviously, the more you get, the more smaller things get, so it's good to keep that in mind as well. So in these images, it sort of gives an idea of the indexes and numbers you would need to include in the subplot functions in order to achieve these layouts. You can also layer over different graphs as shown by the axes functions. These numbers refer to the location and positioning of these graphs in order to achieve that particular layout. So now we are going to move on to looking at contour plots. So contour plots are a way to show a 3-dimensional surface on a 2-dimensional plane. It shows how the variable z, which is a function here of x squared plus y squared, changes as a function of the 2 inputs. So in this case, I'm using contour f, which is the filled case, and it requires 3 inputs. So it needs a gridded x and y data, which is done or created using the NumPy mesh grid method, and z values. So you can also add a color bar, which represents a z value for each of the color through the color bar function, also shown in the code there. There are a wide variety of different color schemes available for your contour plot, with the one being shown here in the output being the default case. You can get, bright pinks and blues, or even black and white if that's what you want. Just depends on your preference. So compared to the other plots, there is an extra step required in order to get the data ready in order to be used. And that is gridding the x and y input data to a grid. So I'll go into a little bit more detail about that. So this is easy to do, and it doesn't take that much extra steps. So all you need to do is use the numpy mesh grid function for your X data and Y data. And this is used to create a rectangular grid of two 1D arrays, which in this case is a list of X and Y coordinates. So it will then return two 2D arrays, which represent the X and Y coordinates of all of the points in the rectangle. The image on the left gives an illustration of how the mesh grid function works. But please note that you do need to grid your data, otherwise the contour function will not accept it, and so this step is quite essential for contour plots. So now we're going to look at some more advanced features that Matplotlib has to offer. The first of these is animation. I'm not going to go into too much detail of how to code this, as they can be pretty lengthy and vary in difficulty, just to show on one slide. However, it is good to know that you can do this to illustrate or present your data in this way. It's great if you have time varying data, etc. So in this example, we have, a traveling wave that is moving, from left to right there. So Matplotlib also makes it easy to save these animations as videos as well. You can use them however you like. You have control over the frame rate to determine how fast the animation is as well. So another thing you can do is 3D plots. In order to use 3D plots, you do need to import an additional statement, which is the mplot3d module from the MPL toolkit. But once you have that, it's just a case of just an extra few lines of getting your data ready in order to do it, and then just plotting. I mean, as you can see from the code there, it really doesn't take much in order to plot 3D. So in this case, we have a 3D line plot, which is quite interesting. So beyond the 3D plot shown previously, you can also make surface plots. As you can see from the code, there really isn't that much extra. Now, it is worth noting that depending on the Python interface you are using, these graphs can be completely interactive. So if you wanted to rotate or look at the surface from a different angle, all you have to do is just simply drag it with your mouse in the direction that you want to go. If you don't have that capability, no worries, you can still change the viewpoint you're looking at. You just need to use the function showed in the code snippet at the bottom, which has elevation and then the azimuth angle, and then it can easily change that as well. So the final advanced feature I'm going to illustrate today is adding text to your graphs. So this is done through the annotate function, and it is majorly used to either add in equations or additional information about key parts of your graphs. If you had any interesting features, for examples, which had labels, that's a really good way to do it as well. So the only issue with these is that getting the location right can be quite tricky, but if you play around with it, it can, once you get the hang of it and, no rough areas, then it's quite easy to manage. So now we are getting to the end of the teaching content I'm going to show. I thought I would add in a few examples of how people have displayed their data using Matplotlib. Based on what we have gone over today, most of these should be well within your reach with a little help from online documentation and examples. It's just a case of practice and just trying things and just seeing what works. So I hope I've illustrated to you all today how useful Matplotlib is in plotting your data and how you can create some really creative, impressive ways to present your data. So Matplotlib isn't the only plotting tool available for Python. It is, however, the most widely used, most documented, and you will find Matplotlib more than enough for what you need to use it for. And I've now come to the end of this seminar. I want to thank you all for listening, and I hope you have learned some of the basics of how to use Matplotlib and also how to learn more complex examples. If you have any questions regarding anything in this seminar, please don't hesitate to send me an email. I will always try and reply as soon as I can, and I'll happily answer any questions you have. Or for more information on future seminars taking place in the series, please visit the Hetsys Outreach webpage linked here as well. So thank you all for listening, and I'll see you all later. Thank you.